Just as a bit of introduction, I'm Gerald Combs. I'm the creator and lead developer of Wireshark. I'm also part of the Wireshark Foundation, which is a nonprofit that we set up for the community and to support the project. During the day, I work at a company called Sysdig, and we focus on cloud security, which is, you might be wondering why the Wireshark guy is doing cloud stuff, and I'll explain that today. And I'm the co-creator and lead developer of Stratoshark, which is kind of the main point of the talk today. Quick overview of what I'm going to talk about. I'm going to talk a little bit about Wireshark just to kind of get us started, but try to very quickly get into Stratoshark and why we created it and what it does and what it can do and what it will do. So this is a slide I show every time I talk about Wireshark. It gives our, just the basic stats of the project, and it is a pretty good-sized and healthy project. But the thing I want to focus on this slide are these two numbers right here, the fact that we support 3,000 protocols and 265,000 fields. That speaks to why Wireshark is so popular and to its power. Now, you guys all use Wireshark, so I'm assuming you're familiar with the fields, all those different fields, but that kind of points out the fact that at its core, Wireshark is a dissection engine. It's actually like a little kid that just learned about dinosaurs or state capitals, and it'll tell you everything it knows about a packet. Instead of saying, well, California and Missouri, they're the only two states with bears on the flag, it'll tell you everything about every field in that packet. It'll tell you where it is in the packet. It'll give you a description. It'll give you the display filter name. It'll tell you what kind of data it is, whether it's a number or a string, and so on. And that's kind of where we get a lot of the power in the application, and it's where we build a lot of features. The main feature probably is the big thing, the text entry at the very top of the main window that lets you build these really complex filters and drill down to the exact traffic that you want to find. And again, you can leverage all these display filter fields. We also support things like coloring the packets. In the packet list, we draw them in different colors. That's built on these display filter fields. And you can graph them. You can graph either the field values or how many times they show up over any given interval of time, and a bunch of other features that we drive. For instance, if you use Wireshark's configuration profiles, and everybody raised their hand here when they asked if they use Wireshark, if you don't use configuration profiles, that's something you should look at. It lets you switch Wireshark's behavior between, and lets you customize it to different kinds of traffic. Like if you have a color interval set for Wi-Fi, you can switch to a configuration profile that lets you load that. And you can automatically load these profiles when you load a capture based on, again, a display filter. I'm going to do a quick run through of Wireshark. It sounds like y'all are familiar with it, but maybe I'll show you something you aren't familiar with. I'm going to put on my glasses so I can see what I'm doing. The thing to notice here is that I run Wireshark from the command line, and that's because I'm a Wireshark developer and I build it several times a day, and that's just how I run it. Probably not what you want to do. This is Wireshark's main window, which you're probably familiar with. I have a bunch of capture files I've opened previously at the top that I can reopen easily. Down at the bottom, we have a list of interfaces we can capture on. I'm going to open up a capture file here, kind of zoom in a little bit. And again, there's this list of packets that are drawn in different colors based on display filter fields. This is a packet capture I took years ago. I had spun up a web server at some cloud hosting provider, and even without assigning a DNS, even without assigning DNS for this VM, I suddenly started getting all these HTTP requests, and they were kind of suspicious. So I instantly took a capture just so I could have it on hand. But as you scroll through, you can do things like go down here and see, again, all those display filter fields that Wireshark gives you when it dissects a packet. I can click down here on this field, source address, and I can drag that up to the very top and drop it in the display filter field. How many people do this instead of just typing it in? Okay, you learned something today. And if I apply that, we drill down to just that traffic. If I, just kind of flip through this and scroll down, I can right-click and I can do, or I can, use a very popular feature of Wireshark that people use all the time, which is I can right-click on a TCP packet and say follow TCP stream, and I can see the contents of that stream. And in this case, we have, again, I had some really weird, shady traffic I noticed on this web server, and if you scroll down, yeah, like I said, without even having a host name assigned to this machine, I started getting all these posts to the web server, and of course, my server didn't know what to do with it, so it said, 404 not found. I have no idea what you're talking about. So I'm guessing the IP address I was assigned was just some sort of used janky IP address that belonged to some sort of botnet or whatever previously. Back to the slides. One of the things I love about Wireshark is that we're part of an ecosystem, and that ecosystem is built around a library called libpcap, which does packet capture, and it does it on Linux and Unix. On the Windows side, we used to have onepcap. Nowadays, we have npcap. But there are a whole bunch of applications and utilities and tools that use libpcap. And if you don't recognize the logos at the top, we have Kismet and Snort and Zeek and TCPdump and ntop and nmap and Wireshark and Suricata. All of them use libpcap to some extent or another. And the thing I love about libpcap is that as a person who develops a protocol analyzer, it let me focus on writing a protocol analyzer instead of having to dig down into the kernel and maybe mess around with the network driver and get packets out of the system that way. When I was very first writing Ethereal, one of the very first things I did was just write this minimum bit of code that used libpcap and got packets. As soon as I saw live packets off the network, I thought, great, I can write an analyzer, and that's what I ended up doing. The other thing is, like with WinPCAP and NPCAP, you can capture pretty much on any platform. But the really cool thing is that there are a couple of file formats associated with libpcap, PCAP and PCAP-NG. And I think this is a productivity multiplier because you can just pivot between all these different tools. Something that I do, and actually a lot of people do, is if you're having trouble on some instance somewhere up in the cloud or some that's hosted somewhere, you can very quickly run TCPdump and get an idea of what the traffic looks like. If you want to analyze that further, you can get a capture, bring it down, and look at it in Wireshark. People do this every day. And people seem surprised when I say I use TCPdump, but I do all the time. It's insanely great at what it does. So this all works great. A good question would be that you can ask would be where we could duplicate this. And that's something my boss looked at, Laurie Stagiani. He was one of the original WinPCAP authors, but he's also started up a couple of companies that I've worked at, most recently at Sysdig. And so the question here was, can we take this success and apply it to things like system calls and log messages and other types of data? And if you're not familiar with system calls, maybe a quick kind of overview. For the purposes of this talk, system calls are the boundary layer in your OS that sits between the operating system and the programs that run on that operating system. And anytime an application wants to do anything interesting, like connect to something on the network, or read or write a file, or play an audio or video, or what have you, it goes through that system call layer. And the neat thing here is that no matter what language you write that application in, whether it's C or Python or Rust or Go or what have you, it's going to go through that layer, and that the layer is kind of consistent, and it's been consistent, well, basically since Unix was invented. And on the application side, it's really nice because as an application developer, I don't have to care whether, if I want to read a file, whether that file is on spinning Rust hard disk or a network share or USB stick or whatever, I don't know, possibly proprietary gears inside this laptop here. It all behaves the same, and it's all the same system calls. On the operating system side, this is nice because if I don't have access to that file I'm trying to read, the operating system can just say no. So as a networking guy, I look at this and I see, okay, there's a whole bunch of activity here going on a system, much like a network segment. And on the network side, if we have a bunch of packets on a network, that kind of defines the network, it defines what people are doing, it defines any performance issues or security issues that might be there. And so that's a similar situation we have with system calls. It's like kind of like a LAN segment we can maybe capture on and pull information out of and characterize that system. And so what my boss and my coworkers have done is develop a couple of libraries, libscap and libsynth. Libscap stands for Library for System Capture, libsynth stands for Library for System Inspection, and libscap hooks into the Linux kernel. It can do it a couple of ways. It can do it through a kernel module or an eBPF probe. Sometimes when I give this talk, people aren't familiar with what eBPF does. It's just this little virtual machine that runs inside your Linux kernel that lets you do all sorts of crazy stuff, including capture system calls. libscap also has a plugin interface, which is kind of cool. It has it has SDKs written for Rust and C++ and Go, so you can write plugins in any of those languages. And we have a whole bunch of plugins for different logging sources like CloudTrail and Kubernetes audit logs and GCP audit logs and so on, systemd audit logs as well, that you can pull in and capture. On top of libscap, there's libsynth. Like I said, it stands for Library for System Inspection, and it takes that data from libscap and enriches it. For instance, if you grab files, if you grab a syscall out of the kernel and say, okay, I want this read system call, the kernel will say, okay, this read is attached to this file descriptor. It's just a number. And what libsynth does is it enriches that. It takes that file descriptor and associates it with a file system path or a network connection or whatever it might match. Similarly, it'll match user IDs with usernames and so on. On top of that, there are three main consumers of these libraries. The two that my coworkers have developed are Sysdig, which is a command line tool, which the name was so great, we named the company and the command line tool the same thing, so we got to make that distinction and try to avoid confusion there. There's also Falco, and I'll cover those in the next couple of slides. My work at Sysdig has been around creating something called Stratoshark, and basically taking Wireshark's code base and that really good dissection engine, and that I consider it a nice UI. Maybe people disagree, but whatever. And apply that to these data sources, these system calls and log messages and so on. This is an example of Sysdig's output. I like to think of it working as a lot like TCP dump, just because that's what my brain's used to. But you can go into a terminal session, type Sysdig, and you will get an absolute fire hose of all the system calls happening on your system. It's really useful, but if you're going to use Sysdig day to day, you should probably learn the filtering language, because that's going to be the first thing that's going to save your bacon as far as being able to use this. But it's a great capturing source, and it's a great source of capturing data. There's also Falco, which is one of the other open source projects that my company sponsors and makes. It's like a host-based IDS, or as this slide says, it's like a video camera. It will sit there and constantly monitor your system and monitor its system call activity and match those system calls against a set of rules. And if any of those rules trigger, it'll send you an alert or do whatever you want it to do, basically. And people use this to kind of keep their Kubernetes and cloud environments safe and secure. But the thing is, with Falco, if it detects something, that's all it's going to do. If you want to be able to forensically analyze what happened, Falco is going to have to log that information out to a file, and then you can pull that file down and look at it in Stratoshark and do some kind of deeper analysis. Okay. I'm going to do a quick demo of basically somebody running this. This is a fairly common thing that people do. I mean, it's a lot of companies say, well, if you want to install our software, just run this this command, curl trustme.bro into bash. And For this demo, I have a few pieces. The first piece is my Ubuntu VM that I have up and running, and I have that command all ready to go, curl, trustme.bro install shell in the bash. This just shows that you can put anything you want into your host file. On the other end of that connection is just this little Python one-liner web server that I have up and running that serves out the file. Finally, we have Stratoshark, which I will pull up here. Let's go ahead and maximize that. So this is Stratoshark. How many of you think this looks really familiar? Good. That's great to see. We have, again, a bunch of capture files at the top that we can open that we've looked at before. Down at the bottom, we don't have network interfaces. We have capture sources. In this case, we have those plugins I was talking about, one for CloudTrail and one for Google Cloud Audit Logs. But the thing I'm going to be messing with right now is this. It's an external capture utility, and Wireshark supports this facility called XCAP, external capture, and this is one of those that lets you capture system calls. On the Wireshark side, you can SSH into a remote host and say run TCP dump. This does something very similar. SSHs into a host and runs Sysdig and does live packet capture that way. And I'm going to go ahead and click on the config option here. And you can see on the server side, it's connecting to, I named my VM Ubuntu. That's what it's connecting to. If I click on capture over here, we can see that we're going to, at the remote end, we're going to run Sysdig. We're going to run it under sudo. And that's because in order to capture system calls, I mentioned before, libscap can either use a kernel module, which you can kind of set that up to do as a normal user, or an ePBF probe, which you can also kind of set up to run as a normal user. The thing that it needs root for is to get that enriched data, and it gets it out of the /proc file system, same as everything else does. If you want to map user IDs to usernames and map those file descriptors, and actually usernames can be done through etc password. Anyway, but anyway, there's some privileged information we need to grab, and we can most easily do it under sudo. I've set the IO snapshot link to 512. When libscap captures system call events and file events, it whether they're reads or writes, it can capture the actual data that was written or read or written. But by default, it only captures 80 bytes of that, which for this demo is not useful. And so I kind of bumped that up to 512. The thing to know here is that I can do this. You can't do this yet if you go download Stratoshark, because it's in the bleeding edge master branch. It hasn't been in. It hasn't showed up on a release yet. So in the next few weeks, when I release 0.9.3, this should be there. I've also clicked use ePBF because that's very convenient, versus using the kernel module. So, okay, we're all ready to go here. So I'm going to go ahead and click the start button down here. Whoop, no, before I do that, I'm going to set a capture filter. I mentioned that libscap was a fire hose, so I'm going to limit what we captured to processes named bash or curl, because I know at least those are involved here. Then I'm going to go and double click on this, and we are now capturing. We're not capturing anything, so let's make something to capture. All right, I'm going to go ahead and hit enter in my Ubuntu VM and run that curl command. And okay, I ran it, and it says, gives you a friendly message, hello, open source summit NA. Let's flip back to Stratoshark, and hey, we have activity. The thing to notice here is that what we're looking at are not packets, these are system calls. Let's go to the top of the window. You can see at the very top, there's this column named event name, and it has all these system call names like pselect and read and write and IO control. There is, I'll get to this column in a second. There's the process name, bash, the process ID, the username, which is parallels, which is what Parallels set up for me. There's this column with these up and down triangles, and that shows off the fact that, like Wireshark, Stratoshark supports dissection plugins written in Lua. And so I just wrote this little Lua post dissector that looks at the file system activity, and if there's a read, it'll add a field with an upward-facing triangle. If there's a write, it'll add a field with a downward-facing triangle, and I just added that as a column, and now I have this little kind of neat visual indicator of what's going on. So what I'm going to do is apply a filter. How many people use Wireshark's filter button feature? If you have a display filter you use all the time, apply that as a button, because you can just bring it up really quickly and apply it. I'm going to apply this filter called pipe writes, which then applies this filter. Event IO is right, or is IO right, is equals true, and the fd.type equals pipe. So any writes to a pipe will match this filter. And sure enough, we have 4 events here. If I click on the one at the very bottom, I can go through and look. And you can see there's some text here. Just like Wireshark, though, I can right-click on this, and I can follow, but instead of following a TCP stream, I can follow the file descriptor stream. So we can see what's in that pipe, which I think is neat. Anyway, so let's see what was in the pipe. We have a shebang for bash. We have hello open source summit NA, and then somebody's trying to use curl to exfiltrate our Etsy password file. That's not cool. It's not useful because password doesn't have any useful information in it, except for usernames and IDs. But so, okay, we've identified some shady activity. At this point, we're investigating this file. Where do we want to go? One place we could go is I'm going to pull up this filter. fd.name contains password. So anytime the file descriptor name contains the string PSSWG, so this would match somebody reading Etsy password off the system. I'm going to go ahead and apply that. And sure enough, there's a curl command reading our Etsy password file. And you can see that down here. I won't follow that stream again just because we kind of know what's going on. What I will do is go down here and look at the detailed information. Just like Wireshark shows you everything in a TCP packet or whatever protocol stack you might be looking at, you can look at detailed information down here. And let me go and zoom in on that for you guys. In this case, we see the process information, whether it's curl or what have you. And there's a ton of process information. Again, libsensp and libscap together just give you all this rich information that you can look at with all the system activity. Even things down to, see if we can find it, the resident state size. So maybe a demo that I need to do at some point is graphing out how a process grows over time. We can do that with this information. But what I'm going to do here is, first I'm going to find there we go. I'm going to find the process ID, and I'm going to drag it up to the top and apply that as a filter. And we can kind of pivot in our investigation here and see that, okay, here's all the system call activity for that curl application, or that run of curl. This might not be useful, but if it were some custom application, this would be very useful because then you could see everything that utility, whatever that program did. We have some time, so I'm going to show one more thing. See if I can find it. Okay. When an application, a dynamically linked application starts up on Linux, you know, it reads all of its shared libraries, right? I mean, I'm sure you're familiar with that. The neat thing we were able to do with Stratoshark was, you know, I have this, I'm clicking on this event where the curl, well, the curl utility is loading up libcurl, because that's, you know, the core of you know, curl's functionality. If we go down here to the process information, we can see at the very bottom, there's something called executable and linkable format. That's not something libsysp is doing. That's something that the Wireshark dissection engine is doing. How many of you knew that Wireshark can dissect ELF data? Not only ELF data, but JPEG and PNG and or, you know, PNG and all this other stuff. Wireshark just has dissectors for not just protocols, but a whole bunch of other stuff, like MP3. So on Linux, Wireshark can dissect the executable format for Linux, and that's what we're doing here. This is the Wireshark ELF dissector. So I can go over here and see just all the information about that executable. And if I needed to kind of look at that binary data, I could, you know, probably want to actually pull that up in another tool, but you can kind of get a good handle on what's going on within Stratoshark and Wireshark. All right, I'm going to close this out and show you one more thing. Okay, I'm going to open up this other file. Make sure I have the right, okay. Again, you know, I've opened up this file. These are not packets, and these are not system calls. This is AWS CloudTrail log information. How many people use AWS? Okay. AWS has this, has a crap ton of services. People, you know, kind of have contests to see if they can remember what all of them are. But in this case, AWS has this really useful service called CloudTrail, and it logs all of the other AWS services, you know, at that service level, whether you know, you're spinning up an S3 bucket or shutting one down, or an RDS instance, or you know, EC2 or what have you, and it logs it out to the format is JSON, and you can pull down those logs, and because we have a plugin for, you know, for libscap and libsysp, we can analyze that data within Stratoshark. And if I click on, let's see, event number 6, it's has a black background and an angry red foreground, so I'm going to click on that and see what's going on. Now notice what happens on the lower right here when I click on this. We go from that hex dump to a nice, pretty printed JSON view. And that's something I added for Stratoshark, but we can also leverage this in Wireshark if we need to. You know, if I go down here, let's see if I can find the event information. There it is. Somebody tried to find out information about a bucket called forged demo env. It doesn't exist, and that's the error message that came back, no such bucket. So that's what's going on there. Maybe that's okay. Maybe that's somebody, you know, a developer in our environment making a mistake. Maybe it's something more suspicious. But at this point, again, we can use all of the Wireshark/Stratoshark functionality to pivot and drill down and find out what's going on here in this environment. Okay. Okay, we're running low on time, so I'm going to quit out of this, go back to the slides. Just to talk about where Stratoshark is and where we're going to be going with it. Right now, you can download Stratoshark for Windows and Mac OS off of Stratoshark, the stratoshark.org website. You can get those installers. You can also run it on Linux, but you kind of have to build it yourself. The sad fact there is that traditionally, well, when I did the very first Ethereum release, all the Linux distributions at the time just started creating packages, and that's just something I haven't had to worry about. And the situation is different with Stratoshark because right now there aren't really any Linux packages yet. Hopefully that situation will improve in the future. As you saw, we can capture system calls locally on Linux. We can also capture them over SSH you know, on a remote Linux server from any platform, whether it's Windows or Mac OS or Linux. We can also capture and analyze AWS CloudTrail and GCP audit logs, and a bunch of other logs, but I call these two out specifically because we ship the CloudTrail and GCP audit log plugins with the Windows and Mac OS installers. And we'll probably ship more plugins as time goes on, but that's what is available now. You can also load captures from Falco and Sysdig OSS, and that's a useful thing that people are doing. Things we don't yet do, but hopefully will at some point. As I said, we don't really have packages you can install from your Linux package manager. Hopefully that situation will change. We have people ask if we can capture Windows system calls, and there is a path to do that. There's a subsystem on Linux called, a subsystem on Windows called Event Tracing for Windows. And there's an external capture utility for Wireshark to use that to get packets on Windows. Presumably, we could use that or something similar to get system call activity, because ETW does support that. We can't capture system calls on Mac OS. Apparently, there's a framework to do that, but I'm just not familiar with it. I'd have to go research that. A couple of questions we get are whether or not we can load strace files, because strace has been the traditional tool to get system call activity on Linux. The problem there is strace dumps out text. Yay, deal with that. So there has been work done to dump it out to a more structured format, whether it's JSON or a binary file, but last I saw it kind of stalled. Maybe that'll pick back up. Similarly, on Windows, the standard tool for getting system call activity is Procmon, Process Monitor. It's part of the sysinternals suite of utilities. It's kind of nice, and it does write to a binary file, so maybe we can get there that way. And a bunch of other things. We have a bunch of open issues in our issue tracker. Bit of roadmap items. I've been making 0.9 releases for the past few months. 0.9, 0, 1, 2, and probably do 3 in a few weeks. And I'm going to continue to do that over the course of the summer. So we will fix bugs and make little improvements here and there. I'm hoping that we can get version 1.0 out maybe late summer, early fall, at the same time we do the next major Wireshark release. What I really want to do to keep my sanity intact is to do major releases of Wireshark and Stratoshark at the same time. Whether we succeed at that or not is something to be seen. Finally, I touched on a lot of moving parts here, and so I kind of made the slide with all the URLs to the different projects. Stratoshark, you can get at stratoshark.org, Falco at falco.org. There are a bunch of source code repositories. Wireshark has its repository, as does Falco and Sysdig OSS. Those two libraries, libscap and libsimps, if you want to look at those and play around with them, you can go at the Falco Security libs repository. I call out that plugins repository because that's where all the plugins are, but it has a README that lists all the plugins that are available, so you can see all the different potential capture sources for log data that you can have available to you. Finally, there is a repository called Falco Actions. It is a GitHub action. How many people use GitHub and their CI system? A couple of you, good. On GitHub, they have this CI system, and part of that is something called GitHub Actions, where you can just run these little kind of components and build software and test it and whatnot. The Falco Actions can spin up Falco at some point in your GitLab CI job and start up Falco, and it'll look at all the system call activity happening in your CI job. And if, say, you pull in a third-party component that does something really shady, Falco will find that out and give you a nice report and maybe alert for you. It will optionally, it can also write out a scat file, so that if you really want to see what that third-party utility did, you can pull that scat file down and look at it in Stratoshark. By the way, I've been mentioning scat files. That's the capture file format that these two libraries use. The scat file format is secretly also pcap-ng, so potentially at some point we could mix system calls and log messages and packets, but displaying that in a way that's useful for humans to deal with is going to be a challenge, but we'll get there. Finally, at the very bottom, there's this GitHub gist for that plugin I was talking about that draws the up and down facing triangles. And if you want to play around with that, you're welcome to. Finally, I make a point to say this at every talk, but Wireshark, I think, is a great and wonderful thing. It's given me this amazing career, and it's let me meet this incredible community, but I can't stress enough that Wireshark and Stratoshark are great and wonderful things, not because of me, but because of all of you, because of the community. And I cannot thank you enough for this life that I live. Thanks. We have about 5 minutes for questions, and I can also kind of hang around in the hallway if, afterwards if anybody's interested. I see a hand over here. Yep.
Well, first, thanks for such a great, useful tool. Really, I got a lot of good usage out of it. I'm excited about the opportunity to possibly use this with to kind of replace strace for some of the work that I do. And I think most of what you talked about makes a lot of sense in terms of like analyzing for security. A lot of what I use strace for is like, I've got a binary utility, I don't really know what it does, but it doesn't do something right in one particular case. And it's like, if I do one set of command arguments, it does something right. If I do another set, it does something wrong. Capture 2 trace files, text compared. You know, and I'm wondering if that's part of any roadmap features, or if there's any pro tip you could tell me about if I'm going to try it out. What should I try first?
The question was, he uses strace in his normal day-to-day work, and if they're and he uses it to try to compare the activity of a command run with different options, and try to see what the difference in that behavior is. And he's asking if Stratoshark has that functionality. We don't. That's an awesome idea. So I will try to add that to our issue tracker, and that's something people do on the Wireshark side too. Because if you have traffic on either side of a firewall, you're kind of in the same boat, and you want to compare that traffic and see what's going on. So. Yeah, that would be amazing. Yeah.
I think I got 2 questions. You mentioned that the logging format for both is PCAP-NG.
Yes.
The file format. Is tooling, has anybody tried working on tooling that to simultaneously capture both packet and system call into the same time series?
The question was if you, since PCAP-NG supports packets and system calls, if we could add those at capture time. Not that I'm aware, but you never know. What you can do, and what I've played around with, is Wireshark ships with a command line utility called merge cap that lets you take 2 captures and merge them. So I will guarantee you, if you take a SCAP file and a PCAP-NG file and merge them today, you'll get, and try to load them in either Stratoshark or Wireshark, you're probably not going to, well, it might crash. Yeah, I just haven't played with it. Last time I played with it, it crashed, so, yeah.
Okay. Second question. I assume this is very early to ask this, but any endpoint protection platforms that have talked to you about adding a filter or adding filters or integrating with this new Stratoshark filter?
Okay, the question was if any endpoint protection platforms had contacted me about it. No, but I do make a company, or I work for a company that makes an endpoint protection platform, so technically, yeah, I talk to those people every day. But third parties, no, I haven't been contacted by any, but they are more than welcome to. I mean, this is that's kind of the typical thing with Wireshark. I mean, it's just something we've done for a long time, and so I expect that to happen with Stratoshark too. Yes?
In the demo which you presented, you were running Stratoshark directly to EF Pro on Linux, but then how Falco is, Falco plugin, how in Stratoshark, how it works. So I have Falco with my own set of rules written. Will somehow Stratoshark work with that set of rules, or how is that?
The question was about how Stratoshark and Falco work together and their rules. They don't work directly together, except Falco might generate a capture file that you could then load into Stratoshark. the thing that they share are those two libraries, libscap and libsimps. And libscap has that plugin architecture, so they can pull in the same data from the same data sources and look at it that way, but they are two separate utilities for good reason. I mean, Falco is meant to run continuously on your system and is very lightweight, and they focus, my coworkers focus on that really heavily. Meanwhile, Stratoshark doesn't have to worry about being lightweight. It has to worry about showing you everything that it can about every event, and so it's much heavier in that regard. So, like I said, we can pull in that same data, and that's kind of where the connection ends, I guess. Yeah.
Yeah, and one last question. In the filter of the Stratoshark which you're typing in, the syntax is very the same as rules, condition, and Falco. Are they the same, or is it coincidence, or?
Okay, this question was about the filtering languages you used. Libscap and libsimps, just like libpcap, have their own filtering language. Like in Wireshark, the question the thing people run into all the time is that we have two filtering languages for capture and for display. And it's just because libpcap has its own little filtering VM with its own little set of filters, and that's what you have to deal with. And Wireshark has those 265,000 fields you can take advantage of. And we have a similar situation here. Libscap has its event filters and its own filtering language. And what I've tried to do in Stratoshark is, the syntax of those filtering languages are similar. They're not exactly identical. But what I've tried to do is make sure that at least the field names are the same. So they're very similar. They're not identical. I kind of have an experimental feature in there that will let you take a Wireshark display filter and convert it to a Falco rule filter. I haven't tested it heavily, so it may generate gibberish, but it's at least there. So yeah, if you're investigating this SCAP file in Stratoshark and you run into something where, okay, I'd like to convert this to a Falco rule, you can kind of use that conversion option to do that. Yes?
bcap support kernel function capture because it looks like there's another project called kernel shark. Literally capture the kernel function.
I'm sorry, I didn't quite get the question.
My question is, could bcap support the kernel function capture?
Yeah.
More detailed than just the system calls.
Yeah. Well, yeah, that's kind of what libscap does. It hooks into the kernel and pulls out those system calls. That component is what does that. Okay. Where are we? Ooh, we kind of went over. Sorry. I don't know if anybody's waiting to come in, but yeah.
Could I set up to analyze USB packets specifically? Is there
Wireshark does that already. The question was if you could analyze USB packets.
I've only done it for network stuff.
Yeah. If you're running on Linux, Wireshark should be able to capture USB, and macOS and Windows. Windows requires a special driver, but yeah, you can do that. Yeah, yeah. This thing, people use Wireshark for USB and Bluetooth all the time. So, all right. Thank you.